I'm gonna get the recording going, and then let's do screen share, screen two, and I can clarify. So you guys, where we're at, you know all about service and repair of AC, and that's talking about condenser, compressor, lines, TXV, that type of work. Now we're going to get into temperature control. So this is really talking about that HVAC box. You had an HVAC box out. You had an HVAC box apart to do an evaporator and a heater core. However, I didn't really have you focus on the temperature doors, the mode door, the blend door. They have a lot of different names. Toyota would actually call them servo motors. They could be called actuators. Um, they have a lot of names, so that's kind of what we're into right now. And then that'll bump right into automatic climate control. Some of this will be the Zoom, some of this will be in person. And then the hybrid will be really all in person. So we're fairly lecture heavy on the remainder of the semester. The biggest lab parts are over. You got to do a lot of R&R. There's still some with the, disassembling the box and looking at different things, but a lot of this is going to be more theoretical. Okay. So with that being said, you guys can see what we got. Chapter 15, 16, Unit 4 packet, Unit 5 packet, which doesn't really have a chapter associated with it. Automatic climate control is covered as part of 15 and 16. They don't separate them. And then hybrid, we do have a chapter, but that's really 13. Thermal management is the heating system. So there's that, but and 14, but mostly this right here will be Toyota specific material in person. And then aux systems, there's very little. The final thing we're going to cover in the final week is diagnosis. So what's pretty cool right here, there's actually a simulator you can go on and do some hypothetical diagnosis using the simulator. You can put gauges on it, you can check pressures, you can check whatever. You should be decent with the diagnosis already, but we're really going to fine tune our diagnosis time. Then at that point, you should be ready for A7. So regarding ASE, you're right, that date is wrong. Let's go over this right now. We got this week, we got next week. So the due date, I could actually keep the 12th. July 12th would be the day after. You will be as ready as you're going to be actually the 10th. The 11th is T10 graduation, so it'll be all hands on deck for that. You guys can eat, help. If you're really, well, we'll talk more about that later. But there will be no actual study session on that 11th. Okay. So 10th is going to be, you should be ready for that ASE. If you want to take the ASE Thursday, okay. If you want to take it Friday, okay. If you want to take it Saturday, okay. Even down in here, it's okay. Summer school, sometimes they make the grade due date a little sooner, but I'd say your safe bet, as long as you have it done by the 18th, we're chilling. Okay, so have it done by the 18th. But you will be as ready can be by the 10th. Cool. Okay, so with that, Madi, I am going to answer that question, but I want to do it with something on the screen to help understand. We are going to jump into it's 15. So let me pull 15 here because I'm changing classes for me here. Just 1 second. Okay, get rolling. 15. 15, I believe I said. And actually 15 is good, but I do want to use the Toyota one has some really good slides for this as well. So give me 1 more second. Okay, here we go. Here we go. Gonna go right off the bat. I'm gonna go here. Next. I'm gonna go, I believe, here, here. All right, this diagram looks like it was drawn by a small child, but let's explain something. Air is coming in a couple different ways. You guys can see this. I'm gonna do a little annotation. Air goes in. You can see that, right? In fact, I'm gonna change the color here. We're gonna just have it be just air. Air is green, goes in. The blower motor is pulling air inward. Cool. You see this thing, air inlet control? What do you think that is? It's kind of like a damper, like a valve door, you may say. Would you agree? So if this swings up and blocks off, the air would actually come through like this. It would come through and be recirculated, right? So can you tell what this air is? Anybody tell? Fresh air. So what would be this one? Do you agree? Can you tell fresh air or recirc? How do you change it? You gotta unmute and tell me. How do you control fresh air or recirculated air?
The blend doors.
Yeah, so the button, like Marty said in the chat, we could say blend doors. Sometimes blend doors could mean a lot of different things, but basically we need to open that door or we need to close that door. Those are the options. Do you want to open it or close it? So fresh air or recirculate could be a button, could be a knob, could be whatever. Cool, but that's this door. So this door is going to have its own method of control. Then air is going to come in, but what's drawing the air in? Anybody know? That thing.
The blower motor.
The blower motor. Yeah, I can see that in the chat. Good. So if you want more air, what would we do? The blower motor.
Spin it faster.
Exactly. Cool. Then from there, the blower motor. Now this is kind of interesting. The blower motor is going to go through the evaporator. It goes through right here. This is the evaporator. Cool. What temperature is the evaporator? Depends on if the AC is on or off, doesn't it? If your AC is off, what temperature is the evaporator?
Ambient.
Exactly. Bingo. But if your AC is turned on, what temperature is the evaporator?
Roughly like 40 degrees.
Or maybe even a little cooler, but it's gonna be cold, right? So if it goes through the evaporator and the evaporator's cold, what comes out? Cold air. You agree? Cold air. And then cold air, depending on this position of this door, could go like this, and this would be cold air. And you get cold air and it feels so, so good. Am I right? But what happens if we move this door to the heat position, which would actually be where it's at right now? This is the heat position. It's blocked off this way. Which way does the air have to go? It has to go up like this through that thing. And what the heck is that piece of crap?
The heater core.
Yep, exactly. I saw it on the chat. You like my writing? Don't judge me. What temperature is the heater core?
About the same as a radiator, like 190.
Yeah, assuming that the engine's up to operating temp, right? So if the engine just got started, it's ambient to start. And that's why your heat doesn't work, right? And I told you this whole hypothetical argument. Now do you see why I was right? you turning on the blower fan doesn't make this piece of crap get hotter any faster, okay? If you want this to heat up, you know what you need to do? Run the engine longer. You could rev it up if you want. The air coming out of this is gonna be what? Sizzling hot. Cool. That's it. Boom. So how do we control whether it's hot or cold? What'd you guys catch there?
Using the doors basically to actuate it, the
Yeah,
airflow.
exactly. Right, so if we took this and we moved the door, we went up here and we picked this color. No. Let's go with that green again. If we move the door up here and open this, now it would be cold air because it would bypass the heater core, right? So it can only be one or the other, and it all depends on what this door is doing. So when you have that little knob and it goes blue or red, you're literally just controlling this door. You want it red, it closes off and it sends the air through the heater core. You want it cool, it closes off the heater core, kicks on the AC, cools the evaporator, and sends cool air through. Kind of makes sense? You like it. Now, Madi brought up a good question. With this heater core or with this evaporator, we have refrigerant going in, we have refrigerant coming out. And if let's just say the evaporator starts to get warm, we want to cool it off, right? So generally what we would do is we're going to close off the TXV, which is going to drop the pressure more. And the lower the pressure, the lower the temperature. But in fairness, and Madi, when you watch that video, what did it tell you?
It tells me it depends on the amount of refrigerant going into the evaporator. So if we want it colder inside the cabin, we needed to kind of open more the TXV valve, the thermal expansion valve. So to allow more refrigerant passing to the evaporator to get it
Yeah.
colder.
Yep, and that's actually right. So what I usually do is I'll explain it in the most simple way. And I still recommend that you think of it how I'm about to say. If the heater core gets too warm, we're going to close the evaporator. We're going to close the TXV to get the heater core cooler. And exactly what's happening, maybe not so much because we may need more refrigerant to go through to basically have that refrigerant evaporate more to provide more cooling. But exactly the details, to be quite honest with you, don't really matter. If a heater core, if a TXV is malfunctioning, we could diagnose that. So in the typical way a TXV would malfunction, there's a couple. One, the TXV has small passage, right? So if we end up with some debris in the system, where does the debris most likely get stuck? What do you think? It's going to be the smallest point in the system. So where do you think it's going to get stuck?
Inside the TXV valve.
Exactly. So now think about a TXV. So if we have, let's make a TXV here. And then see, I want to put a text, but I don't need the text to be so massive. I don't know why this tries to make it huge. So let's just make this TXV. Cool. If we have refrigerant coming in on the TXV, where the heck did the pen go? Am I losing it? Where is the pen? I don't want the stamp. I don't want the spotlight. I guess this is draw. Okay, makes sense. So if you have refrigerant coming in, boom, it's going to go through the TXV. If you have a total restriction right here, let's say it's supposed to be a little tiny passage like this. But instead, you have a restriction right here. What's going to happen to our pressures? Anybody know?
High, low, low.
Yeah, this is going to spike up because you're going to have all this refrigerant. It's going to be like, right? And then I saw that. And then the low side is going to get so low, they could actually go into like negative, like very, very low. Kind of makes sense? So in the moment, that's what would happen. This would be super hot and this would be super cold. But, and that's the best way to think about it. Okay, that's the most simple way. It's kind of like electricity. You know about electron theory, right? Electrons actually flow from negative to positive. Cool. Try to employ that theory when you're trying to diagnose electrical problems. You're just going to be a nightmare. But as a matter of fact, it's true. They've studied it. Do you know how they figured out electrons actually flow in reverse? You can't see them. You have a contactor like a switch, right? It opens and closes. They would open and close that switch thousands, if not millions of times. And then they'd look at it and if this is the positive and this is the negative, if the electrons are flowing this way, there should be erosion from this switch and some metal on this switch, but it's actually opposite. The metal has left the ground and ended up on the positive, proving that the electrons actually go negative to positive. But like on the wiring diagram, if you try to read it like that, you're just going to be confused. So the way I typically want you to think about this is if there's too tight, like if there's a restriction, your high is going to be too high and your low is going to be too low. But technically, I want you to understand something. Your low pressure will be cold, but it won't actually provide as much evaporation. So in the evaporation, remember, that's what really absorbs the heat. So what a TXV should do is like open this up a little bit and it should let some more of that refrigerant flow through. And that refrigerant will then evaporate, which will absorb more heat, but it's latent heat. So it's kind of invisible heat. So Madi, the way I explained it, the TXV regulates temperature, but it's a little bit more complicated than I at least put out. So what you saw in that video is true. When we need to provide more cooling, the TXV could actually open, but I wouldn't really think of it like that. You don't really need to think of it like that. It's just going to sort of complicate it for you. So let's say the TXV fails, your high is too high, your low is too low. That's a TXV that's restricted. Should that TXV open more? Yes, but it's restricted. You'll never get a TXV that's confused. A TXV doesn't do the opposite thing. A TXV doesn't like, I'm supposed to open, but actually I accidentally closed. You know what I'm saying? What'll happen with a TXV is it'll be restricted, in which case your high will be too high, your low will be too low. You know, it's restricted. Now let's just say the TXV, has a problem and it's stuck open. So let's just say that if it's stuck open, now there's too much of a passage here. The passage is going to be too big. I can't actually do what I want to do. If the passage is too big, what do your pressures become? The high is going to drop and the low is going to come up. So now you got a TXV that's too open. The thing is, if it's open that much, there'll be a lot of refrigerant flowing through. So refrigerant flowing through. So you'd think it'd be super cold, right? But no, not really. You'd have so much going through that this high wouldn't be high enough to cause the condensation in the condenser, and this low wouldn't be low enough to cause the evaporation in the evaporator, and your AC would blow warm, right? So what AVI said is true, but like I would never explain it that way to you. I would just explain it just like that. The TXV makes the low low and makes the high high. And if the high gets too high, the TXV will open a little bit more to sort of balance it out. See what I'm saying? Think of it like that and you'll be good. if you want to become an engineer who designs these systems, then you can have a better understanding. You can come back, you can teach me more. I know enough to diagnose the car and I know enough to pass the test. I do not know enough to be a thermal system engineer or something. I just don't, straight up. Cool, so keep it simple, stupid a little bit. And then for us, let's get more into how we're gonna heat and cool the air. So let's assume from here on out that the heater core is hot and that the evaporator is working properly. And let's start with being the air that comes in. Give me a volunteer. Is the air recirculate or is the air fresh air? You guys let me know. What is it gonna be?
Fresh air.
Fresh air, here you go. This is coming from under the cowl. Going in the blower motor. How fast do you want to turn the blower motor? New volunteer.
Max.
All right, so let's say that's max 9, 5, whatever it is, max. This thing is going to be cranking as fast as it can. So that's going to speed up the air and throw a lot more volume of air, right? And it's going to go through the evaporator. And now, do you want heat or do you want cool today? Do you want today? I know it's hot today. You got to be burning. Cool, that's what I thought. You don't want no more heat. So if you want cool, do we want to go through the heater core? No. So flip that door up and go right down here and thank you very much. Cool? Agreed? Because this heater core is sizzling hot. Now, let's just say we had a defective temperature door actuator. Cool? If we had a defective temperature door actuator and the door was in the direction that it is right now, let's say you set it to cold, but the door's stuck where it is, what's that air gonna do? What's gonna happen here? It's supposed to
Stay
go,
hot.
yeah, exactly. It's supposed to go down, but the door's in the wrong spot, so it sends it through the heater core, and you don't get ambient air. What do you get?
Hot air.
Like literally hot air. So if it was 90 at your job and you're getting air that's blowing at 120, you don't have to start checking the compressor and stuff like that. You got to figure out why is that door in the wrong place. You kind of picking up what I'm putting down here? This a lot of times we'll call the temperature door. Sometimes they'll call it the blend door. They can have a lot of names. If it were me, I like to call this the recirc door, right? So the recirc door, let's name them here. We'll name them on screen. On screen it is. The recirc door, and Toyota can call it whatever they want to call it, but I'm gonna call that recirc. Cool. That one. What do you want to call this one here? What do you think?
The blend door.
Temp or blend door? I'll go with either one. If you say temp or blend door, I'm on the same, we're on the same page. I got you. Now, what do you want to call this one here? Toyota calls it airflow mode control. What do you think? On the ASE, a lot of times we'll call it mode door. Like what mode is it on? Kind of makes sense. Is it on face? Is it on feet? Or this is actually windshield, face, or feet. So at a minimum, on a basic system, there's gonna be 3 doors. Recirculate or fresh, temperature, AKA blend, or there's gonna be mode, windshield, face, feet. You ever notice you can put them in multiple modes, like maybe windshield and feet or face and feet, but a lot of times you can't put them on all 3. You might just run out of air volume. Cool. Now, how do you think we're going to control that blower? How are we going to turn it up, turn it down? Several ways. Yeah. So old school resistors, new school ECU is going to communicate and send signals to a transistor. It's really like a MOSFET blower transistor. So got a lot of ways to control that. We're going to get into those details. Now, sadly, this is the most simple type, but it's not the only type. Oh, I thought that that would delete my stuff, so it closed it, but it didn't delete it. How do I delete that? Guess I just get the eraser. All right, so unfortunately though, like I was saying, I like the temperature door system, but check this one out. This one's different. This is review. You've heard this twice. We will have a heater control valve. Hot coolant will come in, but the heater control valve will block the coolant. The heater core will get cool. So if we were to have this type of system, there is no door. We don't need a door. We basically have it go through the evaporator, and if the AC's on, it makes it cold. And if the AC's on, the temperature, the heater control valve, like this, mechanically blocks off coolant to the heater core. What would happen to the heater core? It stays ambient. So then if we have a cold evaporator and an ambient heater core, we have cold air. Then if you turn it to heat, it kicks off the compressor and it opens this valve up and sends hot coolant into the heater core and gets it hot. In which case, this is ambient and this is hot. No need to reroute the air. The air always goes the same way. We just manipulate. Are we making the evap cold and the heater core hot? Are we making, well, you never have those. The evaporator cold and the heater core ambient, or are we having the evaporator ambient and the heater core hot? Those are your two options. That's all really controlled by this heater control valve. So that would be one type. This is not real common. Honda's used it for a long time, but mostly they don't now. So kind of makes sense, right? This is the one we just talked about. This blend door or temperature door directs air this way, directs air this way. You want it hot, you want it cold. Cool. And then this is going to get into what Toyota would call the servo motor. The servo motor ASE will call a temperature actuator. Okay, this is an electric motor, but it's a little bit more than that. So we're going to look on the wire diagram because it's a motor, but it's also a sensor, and that's where there's 5 wires. 3 of the wires are a position sensor. 2 of the wires actually move a motor, and that motor is splined to the door, and it moves the door this way or it moves the door this way. Cool. So we'll cover the other types. And then here's your blower motor. Sometimes they have different blades, you know, to get more airflow or whatever, but your blower motor's right there. This is actually your recirc door right here. If it's up, it pulls air from behind the, like kind of in the interior panel near the glove box. If it's down like this, it's pulling it from the cowl through the wiper cowl. They both send it through the cabin air filter in some designs, and in other designs, you only get cabin air if it's fresh air, but most of them do both, right? And then this gets into duty cycle. So we're going to come back to this blower motor stuff because it's a little bit more complex. So the first part of the Toyota one is really good. It's basic. And then what we're going to be into is more the book, which I have right here. So here we go, jumping into it. There's cabin air filters, dirty and clean. Cool. Sometimes it's push button. It could be various modes, various types of things. Here we have a door that has a cable on it or a rod, and this is the door right here. So this is a heater control valve, and this is the valve that either blocks coolant or allows coolant. You can see heater off comes from here, is blocked. You start to turn it on, it starts to let hot coolant go to the heater core. That's how you make heat. But what controls that temperature, that heater control valve? Can you guys tell from this picture? The heck is a vacuum servo? Yeah, so this is old school. Back in the day, you'd have a little slider to change temperature. And if you're doing the slider, a lot of times it was hooked up to a cable, and the cable would move that control valve. But there were also cars, because the cable, you'd feel resistance, it felt kind of cheap. There were also cars that have just a little slider, and that would port vacuum to that. So you'd have vacuum going to your control panel, And when you move it, you could actually hear a little pss, pss, you could hear the vacuum flow. It was kind of fun. Vacuum would go to this, and if the vacuum starts sucking on this, it has a diaphragm. When I say diaphragm, I want you to picture like a rubber disc. If we apply vacuum to this side of it, it's gonna actually pull it, and that's gonna open up that door. So we'd literally control it with vacuum. It's kind of cool. It's old school. That would be a vacuum actuator, and that was for a heater control valve. But like I said, most of those are gone. We're using a temperature door. So here's your blend door, your temperature door. Cool. Now, how is this one controlled? If you look, this is a vacuum servo. And by the way, it's not all the way open or closed. You could have it be like blended, therefore the blend door. You could have, you know, if your AC is blowing really cold and you put it slightly to warm, you can actually mix a little bit with the heater core and get not freezing cold, ice cold AC. You get slightly more warm, right? So those are two types, like we said. There's your blower motor, which is here, and the squirrel cage. They come as an assembly for you. But if you got a really cheap one, it won't come with that. Now, here's a basic diagram. The only thing I don't like about this is it doesn't show that one servo or one motor or actuator actually controls vent, defrost. So here's your mode control, vent, defrost, floor. See, all these a lot of times are controlled by one, and there's some complex linkage so that when it moves, it'll close two doors and open one, or open two and close one. And like, they can be a little bit crazy. Like, I'll show you a picture of one just so you can visualize what the heck I'm saying. A mode door, let's call it a mode door actuator. I'll say linkage. Sometimes we'll have something like this. It's a lot of times even more complicated. You know, something like that looks kind of janky. We have one at the school that I'm gonna show you as well. See, like this has got some different gears and linkage. It moves this door, but also moves this door. That one's got like some sort of cover over it. So these can be a little complex. Like you see these, looks all sort of crazy. It's because it's got to move multiple doors at once with one motor. It's just the way that they are. Even this one, and this one's stripped out. That one's damaged actually. That's kind of a sad one because you can't just replace the actuator. You're gonna have to replace that blower, that box, the HVAC box. Fine, so you can see they vary in design, but this has got one right on it. This one actually comes with the door is gonna ride in this little track, and a different door is gonna ride in this track, and a different door rides in this track. So it's potentially moving three doors at once when that motor rotates. Kind of crazy. But if you can just visualize that, then this does work pretty well. And you can see it's either gonna have outside air or inside air. So that's your recirculate door. The blower motor, gonna send the air through the evaporator all the time. It always goes through the evaporator. It doesn't go heater core or evaporator. It always goes through the evaporator. Who can theorize why would we always send it through the evaporator even when it's cold out? Anybody know? If it's cold outside and let's say that, or even if it's not that cold outside, let's just say you don't want AC, why might we run the AC anyway, even if you don't want to be cooler? It shouldn't freeze, but think about what it does. Because this gets cold, if we run the AC, it condensates water. Would you agree? If it condensates water, can't that help dry the air so you don't get fogging on the windshield?
Gets rid of moisture.
Yeah, exactly. That's right. So if you put it on windshield, like defog, it may turn your AC on without you even knowing. So it's kind of funny, like if you put it on fresh air, a lot of times you'll be like, if you put on fresh air and defog, all of a sudden you'll be like, man, that air's cold. It may be running the AC. I've also noticed if you put on recirculate, a lot of times they're worried about this thing getting wet and getting kind of nasty. So if you put it on recirculate, rather than risk building up mold and stuff with your wet, moist air, it'll run the AC. It'll actually kick the compressor on and cool this down, and that'll keep it from getting like kind of musty and smelling and getting growth on it. So they'll run this evaporator core on and off. They may run the AC, but they're always gonna have air going through it to keep that thing kind of clean. Make sense? The heater core a little different. If you heat the heater core up, it'll kind of like burn the bacteria. So we don't have to have the air running through that all the time. Right? So depending on what the blend door does, send it through the heater core for heat, or block the heater core off, in which case it only goes through the evaporator. So if you put your temperature on cold but leave your AC off, that's why you only get ambient. Because if your evaporator core is not cold by the AC compressor kicking on, it's just ambient. You'll get cool air. So now I'm gonna make you laugh. You know, at times I talk some trash on different crafts and trades. And it's not really fair because you never want to judge someone by you want to give someone the benefit of the doubt and judge them by them, not just by what job they do. But unfortunately, this salesman's part of the reasons that I don't automatically have a lot of respect for salesmen. There could be good ones, but this guy wasn't one. And sadly, I've met 100 of them and I'm not real impressed, generally speaking. So this guy was working at the Kia dealer. He went to sell a Kia Rio. And the guy was like, you know, the customer's like, oh yeah, I'll buy the car. And they were selling them cheap too. I think you could buy a Rio at that time for like under 8 grand, brand new. It's nuts cheap, crazy, cuckoo cheap. But the really cheap one was pretty stripped down. It didn't have a lot of options. And so he said, yeah, you can buy the car. It's cheap, whatever. And he said, okay. And it's got you know, power locks, power windows and air. And the salesman said, yes. So he delivered the car. The customer came back literally an hour later saying, the AC doesn't work. They dispatched the car to me. I opened the hood. You know what I found? Not equipped. It doesn't have AC. Now, they don't really do that anymore, but they used to. So it doesn't have AC. What are you going to tell this customer? What do you think the service department told this customer? Homie, you bought a car with no AC and you're bringing it back to service saying that the AC blows warm. It doesn't have AC. That's why there's no AC button. And what do you think the customer said?
I didn't know.
Didn't know, but he also said the salesman told me it had air. So we're like, bring the salesman back. The salesman was an idiot. I'm telling you right now. Salesman was a ding dong. And so he's like, well, I told him it had air. And the customer's like, it doesn't. And he said, well, it does. If you put it on cool, it'll blow cool air. He was like, air means air conditioning. Seriously? They had to buy the car back. They had to buy the car back and get him a car that had AC. So make no mistake, every car you can put the temperature on cool and get air. Okay, that nobody's asking for that. But you understand that was the best you're ever going to get. It was just going to not run the air through the heater core. That's what ambient is. Ambient is just air. That's it. Which technically it had, but it's still dirty. That was misleading. And plus, that salesman was so dumb, you don't even know. All right, so just air would be air running through the evaporator core, but the evaporator is not cool. How would you make it air conditioning? You saw this when we did our work last week. How do we make that thing icy cold? Compressor, TXV is running, right? We're going to do the air conditioning refrigerant cycle is going to work to actually get that lower than ambient. Totally understood it, right? Good. And then the blend door is going to control, or the mode door is going to control where the air actually discharges. Cool. Not exactly rocket science. This one, for example, is mode face and feet, feet and defrost. This one is actually, I gotta tell you, I don't recall this one. Defrost or defog, defog and feet. I don't really remember what the difference is between these two. I think that might actually be running the heater. Kind of a weird one. Okay, so 3 different types. We've got cable. Cable, you can feel the move. You jump in a car that has cable and you go to move the slider or the knob or whatever, and there's no resistance, you better follow that cable and see where it's disconnected or broken. We've also got vacuum types. Like I was saying, there will be vacuum run from the engine to the panel, and then the panel will send the vacuum to the correct place and actuate those vacuum servos. That was old school. But they have physical vacuum lines actually running through the firewall and running back out. It's kind of a mess. And then much more common is the electric servo. And so we're going to spend a lot more time on this one. It has a motor and it has 3 wires for a sensor. And that one can not only move the door, but it can tell where the door is. So I got a question for you. Now knowing inputs, processing, and output, is this an input or an output? What do you guys think? Inputs are sensors, outputs are motors or actuators. So what is it? It's an output because the motor, but what else is in there? It's a motor and a sensor. So these can fail in different ways. The motor can go bad, in which case it won't move. But the sensor can go bad, in which case it has the power to move, but the sensor doesn't know its position. It would likely set a code. Right? So you know, they're both. It's an input and an output in one. And you can't change the motor separate from the sensor. And you can't change the sensor separate from the motor. You just get the whole actuator. And in that little box has both, okay? So here's one where you're, pressing buttons. Now, this one has the left side temperature and the right side temperature. So what do you think that means? How can we have hot air? Well, it depends on who's driving, doesn't it? So now I'm gonna get myself in trouble here. If it's you and some sort of sweet spouse or something, you might have a disagreement on the temperature. But let's just say the driver, we won't say who that is, the driver wants it cold and the passenger wants it warm. We have the technology. The drivers can go cold, the passenger can go warm, and everybody is happy. Yes, they have multiple blend doors. They have one heater core, one evaporator core, but the air gets split and you can have air for the drivers going to the evaporator and air for the heater going to the driver, to the passenger, sorry. Right? So they're split. Now, these systems can have their own issues. So it's not real uncommon, especially like on some of the Lexuses, one of the temperature actuators goes bad. You'll have cold air on the right and warm air on the left, but you'll have them both set to cold. That'd be a dead giveaway. Check for codes, see if it has codes for the actuator. Even if it doesn't, you need to be inspecting that actuator. Cool? That happens. So manual type, semi-automatic, let's go over those. Manual means you control everything. You set the blower motor speed, you set the temperature, you set where you want the air to come out. Cool? Simple. Semi-automatic. Operator controls the blower motor, where the air goes, and you can set the temperature, but a lot of times you can have that computer, you can basically, if you put in the temperature, the computer can move that temperature door as needed. It won't change your blower speed. It won't change where the air goes, but it can move your temperature to gives you some like basic maintenance, right? You set it to 67 and you just go with it. Cool. Fully automatic is where we talk about, oh, I thought it actually covered, this is semi. Well, I'll jump to fully. fully control blower motor speed, where the air blows, and the temperature, okay? But I forgot, these go in sequence, so we're still in the semi. Here's your semi. It's kind of the same. We can have different vacuum servos. The only thing is, this blend door can be computer controlled. It can be manual, but if you put it on auto and all it controls is temperature, that's a semi. You don't really need to know the terms all that well. You just have to understand, if it's a semi-automatic, that means it has to have a temperature sensor, and that temperature sensor has to be reporting to a computer, and the computer has to have the ability to control the actuator without your input. Not real complex. You generally won't see that on a heater control valve type. So here's the automatic, right? It can control all of them. Cool. So we'll jump right to here. This is where it gets a little technical. Here's your HVAC ECU. It's got all these inputs. It needs to know all those inputs so it can refer to its programming to make a good judgment on an output. Make sense? So let's just say you jump in the car and your window is all fogged up and you press the button that says defog the windows. It needs to know what's the ambient air, what's the cabin air. It may or may not really need to know the sun load at that time, but it needs to know what's the temperature of the evaporator, what's the temperature of the coolant. All those are important inputs, but additionally, where is the blend door? If it's trying to defog and it's cold, it's probably going to favor the heat, right? So it's going to look at the temperature inside and outside and say, oh yeah, let's run the heat. And it needs to know the blend door position, right? The blend door position. And if you're trying to defog, do you want fresh air or recirculate? Somebody give me an input there. You want to defog, you want your dirty, your moist air you're breathing, or you want some fresh air?
Some nice fresh air.
Definitely. So it needs to know, what are the positions of all of these actuators? These are sensors. Then from there, it's going to say, okay, here's our plan. We're going to move the blend door to hot. So it's going to use the blend door's sensor as an input, but use the blend door's motor as an actuator. Okay. So when it uses that motor, it says go to hot, and then it's going to say take it off of recirculate, and then it's going to say close off face and close off floor, make it all go to the windshield. And it's going to say blower fan speed. We're going to ramp that up. So the blower is only an output. It doesn't need the AC in this case, but let's say that it knows it's going to get it a little more dry. It may actually turn on the compressor clutch and modify the displacement to get the evaporator cold, just to dry the air more, right? It'll do all this automatically. So you tell me again, what's the role of the HVAC ECU? Anybody? Don't make me pick on someone. I can pick on someone. It processes inputs, that's true. Jimmy, pick anybody you want. Roll somebody under the bus, friend or foe. Pick somebody, Jimmy. Luis, what else does the HVAC ECU do?
Doesn't it control like what goes from P or to anything else?
Okay. So Jimmy says it processes input, so it looks at sensor data. And then you're right, Luis says it controls outputs. So it can control the blower, it can control stuff. We've covered this with ABS. It's a lot like your brain. Okay, these engineers are smart, but they're kind of copying stuff that's already been done. Like, oh, I know. I've got a brilliant original idea. We'll make an ECU and it'll kind of work like a brain. We'll make sensors that are sort of like your senses, which is why they call them sensors. And they'll make actuators, which are kind of like your muscles. Make sense? We're doing this all the time. You get the concept, you can figure some stuff out. Cool. So that's the process of inputs, processing outputs. Cool. If you can understand that, you can already mostly understand automatic HVAC, and we can go in a little more detail. Here's your electric actuator. So remember, 5 wires, 3 of them are position sensor, 2 of them are motor. Vacuum actuator, this is gonna get vacuum or not get vacuum, depending on the position of the switch. These are gone. But there might be a little bit on the ASE still, sadly. Cool, so this is automatic again. There's all these inputs, there's all these outputs. Cool. That's a HVAC ECU. They can be in different locations, they can be all over the place. But right here, let's discuss this a little bit more. We're gonna do some drawing on this. I told you there's gonna be some electrical. There's definitely gonna be some more electrical in person, but for now, we'll have a look. Ground. What should we have on ground? What voltage? Ground literally goes to ground. That's a 0 volts. A and B get a little tricky. A lot of times, what these will be, I'm gonna make red something like a 5 volts. It's gonna go up right here. I'm gonna have a 5 volts. And the 5 volts would be provided by the HVAC controller, by the way. So the HVAC controller gets source voltage and it regulates it to be like 5.0, 4.99, 5.0, 5.01, but basically exactly 5. Even though your voltage may go up and down with the alternator, the computer's job is to give a flat, straight, even, clean 5 volts. Cool. That's why we use a 5 volt reference, because our source voltage is kind of all over the place. We'll clean it up to a 5. What do you expect to be on terminal A here? Anybody want to take a guess? What do you think?
For signal?
Close. So exactly, close, but not 0 and 5. We always give it, like, here's your whole range, okay? This is your whole range. 0 volts would be an error, 5 volts would be an error. We'll typically pick it up around a 0.5 volt. And we'll typically run it all the way up to about a 4.5. We do that using a voltage divider or a similar circuit, so that if we have, let's say, a bad ground, we get a full 5, that'll set a code. If we had 5 volts that was lost, we get 0 volts, that would set a code. Anywhere between 0.5 and 4.5 will not set a code. Even if it's malfunctioning, if it's within the voltage range, it will not set a code, okay? So if you have this sensor all the way clockwise, it may read a 0.5 volt. If you have it all the way counterclockwise, it may read 4.5 volts. If this is a blend door and you wanted it dead in the center, what's the voltage going to be on this actuator, terminal A? Dead's at 2.5 volts. That's right. So that's all. When you get voltage like that, that's a sensor. And it could be 0, or it could be 0.5, and it could be 4.5. It shouldn't be 0 and it shouldn't be 5. Those set codes. In the middle be 2.5. Cool? This is all the sensor. If you have 0.5 volts and that's full cold and you want full hot, what is the motor going to do? What do you think? Let's say it sends 12 volts here from the ECU. What's it going to provide here? Going to give ground here. And that's going to make this motor go. Brrr. Well, how long is the motor going to run? How long is the motor going to run? Because if the motor runs too long, you realize it'll snap the door off in the box, right? So if the motor runs and runs and runs, something has to signal when it's supposed to stop, right? So it's going to run until this input shows 4.5. When the input shows 4.5, that's an input to the HVAC controller, and the HVAC controller says like, whoa, hold up, stop right there. Cool, and then you know what it does? I don't know, it cuts either the 5 volts or the 12 volts of the ground, I don't know, cuts one of the two. And then let's just say, because you're crazy, you're like, no, forget this, I want it on cold. And you bring your slider all the way back to 5, and this thing's like, oh crap, I got a new input. Now we want it back at half a volt. How's it gonna get it back down to cold? It's gonna make ground on this red wire, and it's gonna make 12 volts on that purple wire, right? So you know what what did we call that? You've done that in electrical. What do we call that when you switch it? Reverse the polarity of the motor. That's it. It reverses the polarity of the motor, and it says run motor, but run backwards until I see 0.5, and then I stop it. You see, so that's an actuator. 3 wires for the sensor, 2 wires for the motor. The 2 wires are an output, the 3 wires are an input, but it really only cares about the signal wire, and it's going to be 0.5 to 4.5. Anybody got any questions on that? You have to understand that there will be diagrams on temperature actuators. Do you understand what the heck I just said to you, man? Good. Because you're good. Yeah? You have a question? Yeah? Oh, see that? I left this weird little thing. It's the ground. All right, cool. But those aren't really super complex. I think you can understand those. We're definitely going to do some more in person together. Now, let's say, okay, here we go. We got a blower motor now. You guys remember duty cycle, or you forgot about all that? Because this is one that is controlled by ground. So there's positive side duty cycle and there's negative side duty cycle. On a positive side duty cycle, the blower motor gets 12 volts all the time, and we pulse the ground. So let's take a look at this right here. If the blower motor has 12 volts and this voltage is being pulled off of the ground wire, I'm going to draw it, right? Here's your positive going to your motor, but your motor for now, let's just make it look like a light bulb because I know you guys like familiar things. And then this is the ground. And then in this picture, looks to me like you got 12 volts here, right? But what do you have here? If you've got 12 volts on both sides, is that light gonna light? Why is that light not gonna light? Agree. Exactly, there's no difference in voltage. What we really need, you know what we need? I know. We need to actually wait for it to be here. Oh yeah, right there. Boom, now we have ground. So if we have 12 volts in ground, guess what happens to this bulb? Ooh, makes lights. If you picture a bulb, no problem. But you know it's not a bulb in here, right? It's a motor. If a motor gets 12 volts in ground, the motor turned on. The motor turned on, and then guess what? It turned off. So if this was, let's say, 70, and this was 10, this would be a 10%. Sorry, that was 70, this was 10, and this was 20. Which is kind of weird. Usually these are the same, but we'll go with it. This would be a 10% duty cycle. Cool. So is that motor turning fast or no? It's not turning that fast. How would we turn it faster? Maybe give it a little off and then give it a lot of on. On being 0 volts. Remember, because this is controlled on the ground side. Shoot, let's give it all of it. Now right here, you get like 2%. That would be like a 98% duty cycle. That's, and a lot of times we don't run a full 100, but we could. That would be like basically full speed right there. Cool. So that would be a duty cycle controlled or pulse width modulated, they may say, on the ground. We can control blower motor like that. There's gonna be a couple other types of blower motor controls that we use as well. Cool. Any questions on that? So far good, so far decent. Cool. Alrighty, and then we've talked about this a little bit. So typical thermistors. This would be normal, more normal. So in nature, you'll notice a lot of recurring themes. If you get a wire hot, what happens to the resistance? Resistance goes up. That's just normal. I mean, you get something hot, the resistance goes up. Thermistors are the freaks of nature. It's like, oh, if it gets hot, my resistance goes down. Like, no, wait a minute, but everything else works the other way. Why you gotta be different? It's a thermistor. The problem is they're really very accurate and they have a very close linear relationship. Temperature and resistance are very, very tight on those. So we use them. NTC is the only one we're going to talk about. PTC doesn't even make sense. They exist, but we don't really use those. In an NTC, the warmer it gets, the lower the resistance is. So if you needed to do a PTC, a thermistor diagnosis, you do it two ways. You can measure resistance. Let's just say, like in this case, let's make the temperature 100 in honor of today. And all of you who worked outside, it was rough. Even inside was rough. 100. What should my resistance be at 100 according to this chart, which would be in service info?
4 kilo ohms.
Yeah, sorry, that line was super crooked. I can't even look at that myself. I'm trying to get to 4, but you see, I just suck. Let's gonna start over here. Boom. It's more or less 4. That's kind of going down, but cool. Now, if it's 100 and it's reading 8, what would you say?
Something is probably wrong.
Yeah, so that happens. That's how thermistors fail like that. That would be called skewed. If your resistor is reading out of range based on the temperature, it's skewed. Can you see how that's going to have an effect on the system? If your evaporator core temperature sensor is reading, let's say 30, when it's actually 60, it's going to think it's blowing cold air, but the air is going to be ambient, more or less. It's not going to be that cold. And you could recharge it. You could do all this diagnosis. It actually may or may not set a code. You could probably go in TechStream, look on live data and see what the temperature reading is and compare it to the actual temperature. But if you had to measure resistance, you could diagnose, is this thermistor in spec or out of spec? If it's out of spec, it needs a new thermistor. Crappy thing is, like with an evaporator temperature sensor, those things are nearly impossible to get to. You might have to pull the HVAC box. Maybe you could do some testing on the lead that comes out, but maybe not too. Cool. Right, there's your temperature sensor right there. Just like what we were saying. Testing that can be easy, testing that can be difficult. And then again, this is like a type of image that'd be straight from the service manual. It'll give you this range. Depending on the temperature, this will be your resistance. Cool. And that's literally what you'd see in service info. That's true for ambient temperature sensors, cabin temperature sensors, any temperature sensor, engine coolant temperature sensor, whatever, all work the same. Cool. Now here's one that's called an aspirator tube. So the purpose of the aspirator tube is, you know how, like, if your AC is blowing cold, like let's say you got your AC set to 60, the air coming out of there will be much lower than 60. You know that, right? If you actually put your hand there, that air is cold. So if we have a sensor and the sensor is getting hit by the cold air, it might start reading like 50, and then it's gonna start turning the heat up. So when we have a temperature sensor in the cabin, we wanna locate that somewhere else. We don't want that getting hammered by actual regular fresh air. So if it's a true sensor, it may have an aspirator tube. I have heard them called sample tubes. But if they're talking about a TXV, sometimes they'll call the TXV tube a sample tube. That's actually just for controlling the TXV restriction. So it can vary. We need to know if it was about a TXV or about automatic temperature control. Okay, I'll come back to that question too when we're in the study session. Here's your cooling temperature sensor. Again, it's a thermistor. We diagnose the same. Sun load sensor, that's an interesting one. I don't think I told you this story. I have several actually, but this will be a good example. I have actually two really similar. I'm thinking about which one I want to tell you. I had a customer with, did I tell you about the automatic HVAC question that was blowing cold? No, that was blowing warmer than it should be. And it ended up being the dash cover. I thought I told you, but I couldn't remember. So if you remember way back to then, this sun load sensor is an input because when you're in the sun, it needs to blow colder. And when you're in the dark, it needs to blow warmer. And they program that into HVAC ECU. So when you're in the sun, how does it know? It knows because of the sun load sensor, right? So if you, for some reason, have an issue with one of these inputs, it's going to have an effect on the system. In this case, yeah, they got the nice dash mat and it didn't have the cutout for the automatic ACE, for the automatic temperature control that had the sun load sensor. Yeah, kind of a fun one. So just knowing about how these work, here's the AC pressure sensor. So again, 3-wire sensors work the same. 5 volts ground, and the center wire is going to be 4.5, is going to be half a volt to 4.5 volts to indicate pressure. There might actually be a gauge, there might actually be a chart in service info saying like maybe half a volt is 40 psi, or maybe lower. Let's say 10 psi. 2.5 is 200 psi. 4.5 is 400 psi, right? So the voltage will directly parallel a specific psi. Cool. There's humidity sensor. We don't do a whole lot with that, but it's possible. I think you guys are good on relays. Deblower motor. When we talk about deblower motor, we do want to talk about this resistor. Now we may do a little bit more of this in person, but for now, do you see these resistors? They're like coils. The smaller and the more long, like it'll be wound more. That's a resistor, and the longer it is, the more resistance it has, and they tend to be smaller. Figure that would be a lot of resistance. So if you run current down this one through this wire, this is going to drop a lot of volts, which is going to leave less volts for the blower motor. What speed would you say that is? Fast or slow? What speed would you say? It has more resistance, so it's going to drop more voltage, which means there's going to be less voltage for the actual blower motor. So that's going to slow it down. Make sense? Sorry about that. So visualize this. Gosh, visualize this. But we're going to do the wiring diagram like this. Cool. Speed 1. Coming with the annotate. Let's make it blue. Voltage, voltage, voltage. This is off. Let's make it speed 1. Speed 1 goes through not 1, not 2, but 3 resistors. And combined, let's say it's going to be like, let's say each one of these pulls 3 volts. So there was 12, right? So after the first one, we have 9. After the second one, we have 6. After the third one, we have 3. This poor blower motor gets all of 3 volts and the thing's just turning slow, right? So here we go, we put it on 2. Boom, we put on 2. Look, it starts with 12. So then it goes to 9. Then it goes to 6. So this thing gets 6 volts, still turning slow, but it's faster, right? So we put on 3. It goes to here, starts with 12, and it loses 3. So how many volts are coming out of that one on speed 3? 9 volts. Ooh, it speeds up. Now you put on full speed. Guess what happens? It bypasses all the resistors, taps in here. That motor gets a full 12 volts. Sucker's whipping. Make sense? That's your basic blower resistor. They can work a little bit different, but that's your basic blower resistor. It goes through all the resistors, 2 of the resistors, 1 of the resistor, or no resistor. And there's your speed 1, 2, 3, and 4. You have one with more speeds, it could have more resistors. But if it's newer, it's going to use that duty cycle. And the duty cycle is going to be computer controlled. Okay. So we used these before we had computers to control it. And we had some computers, but it was like, you're going to have a computer for the HVAC. We don't need that. Just use the blower motor. Cool. Any questions on this right here? You just got to know electrical through and through. Let's just say that, for example, by chance, you had 1 volt on the ground. What's that tell you? It's high resistance in this circuit. Exactly, I saw that. So that would mean even on max, you're only getting 11 dropped. So that's not going to turn as fast as normal. Anything that would cause a bulb to be dim will cause a motor to be slow. Okay. Cool. Now this one is similar, but just a bit different. You can see low goes through 3 resistors, speed 1 goes to 2, 2 goes to 1, high bypasses the resistor, but actually powers up the coil side of a relay. If it powers up the coil side of the relay, this is magnetized. What happens here? This thing whips over, click, boom, and then full 12 volts right from the source gets to the motor. Okay, so if you ever jump in a car and you turn up, and then you turn up to the high and you hear a click, that's this type that has a bypassing relay. Aiden's, I believe, had that because as he was moving it, nothing was responsive, and then all of a sudden you get to high and it's like click and it's running full rip. So that is why Aiden's grandma, if you were in part of it, I'm saying if it only works on full, that means the relay works. I would bet my bottom dollar we got an issue right here. It's possible you have an issue here, here, and here, but why would you have 3 problems all happening? It's not likely. You've got an issue in here, and then those will all be dead until you hit full speed. I wouldn't even go crazy on the diag on that. I would say actually, as soon as I jump in the car and it only works on some speeds, I got it pretty well diagnosed. Now, let's just say this resistor is bad. What happens? You guys tell me, what's the customer experience? This resistor is burnt up open circuit. Okay. It would work on high speed, but would it work on every other speed? What speeds would work and what wouldn't work?
A low speed would not work.
Only low. Because only low uses that resistor. Make sense? And if this one was messed up, this one wouldn't work and this one wouldn't work because they both have to go through that. Make sense? And if this one was messed up, then all 3 of these wouldn't work, but high still would. Cool. Again, not really super complex. These are just the electrical questions from AC. I think going over it once, you'd probably be pretty solid if you remember electrical. All right, so if this is a positive duty cycle, this would be on the 12 volt side. It's 80% on, 20% off. That'd be 80% on a positive. If it's on the positive side and it's only 30 on and 70 off, that's a 30% duty cycle. But again, they can be on the positive or it can be on the negative. Just remember that. A little more about the doors. I think we're probably pretty solid. Here's an actual vacuum controlled servo with a vacuum line. Again, you might see maybe a little bit of that, but in real life, I don't think you're gonna see much. They do sometimes have, figure the vacuum comes from the engine, but, this is a thing I usually explain that's probably not gonna be on there, but I'll still explain it. When you go wide open throttle, does anyone know what happens to your manifold vacuum from when we talked about vacuum boosters?
You lose some vacuum, right? Or the vacuum goes down.
Yeah, if you're full wide open, you'll probably have zero vacuum. So if you have zero vacuum, how is this supposed to hold it in the position on a vacuum actuator? Think about that. Give you one clue. We put a little check valve here, but what's this bulge right there? We call that the vacuum reservoir, but I call it the Death Star. You know why I call it the Death Star? Now you know why I call it the Death Star? This is a vacuum reservoir on a blazer. I got totally slaughtered on one of these. I had the weirdest AC concern. They'd say intermittently the AC would blow to windshield rather than face vents. And it was like, and the AC would blow warm. It's like intermittent. I was like running around, going all over the place. And then after finally going back and forth with the customer, they said, well, I said, like, I can't get it to do it. They said, well, if you go up this particular big long hill coming up out of the Hudson River Valley, which is a long hill, and it'll consistently do it. So I'm like, whatever, I'm down, let's go. Boom. I drive way out of the way, way out of the zone of typical road test. And I drive up it, and sure enough, as I'm getting to the end of the hill, AC blows warm and it all blows windshield. I'm like, what the heck? I didn't learn about this in school. So I was racking my brain. I ended up talking with my mentor, which is like the last resort. And he's like, oh, check the vacuum reservoir. I'm like, what? It's got an intermittent AC concern. And then I thought about it. I'm like, oh yeah, it's vacuum controlled. This thing had a crack. So driving around, the engine made more than enough vacuum. But when I went wide open throttle, it should be enough to store for like a nice long hill, but this thing had a crack in it. So it was actually leaking vacuum. It was leaking vacuum, so air was rushing in. So if you went up a long hill at wide open, it would deplete all the vacuum, the Death Star. And with no vacuum, it would go to a default, which was windshield and warm. And I don't remember if it was fresh air or recirculated. I don't think you'll see anything like that, but I wanted to mention it to you just so you A, learn from my mistake, and B, just understand a little bit better, and C, just in case. Cool. So it was a cracked vacuum storage tank that caused that. All right, electric servo motors, as you can see, that's where we're going to put our effort in. So if you look, this one is going to tell you the position. And so you could actually view the position in percentage or in volts. They call it in counts sometimes. And you could command it to go one way or the other way. Make sense? It counts the number of steps to actually opened or closed. Sometimes you had to even initialize these so they would learn the maximum and the minimum. Right? So here's what that looks like. Position sensor, motor, cool. Not that complex. Talked about a little bit. These can vary in all sorts of ways. This more than likely from a Hellcat is probably the computer. If not, this is an input panel to a computer. It's new enough where it's going to have an HVAC ECU. Make sense? So if you want to troubleshoot this, you're checking for codes. You can go in and you can look on live data and press each of these buttons to see if the buttons work. You don't get back there and start back probing. You're going to do really the bulk of that through live data like this. Okay, that's your workhorse scan tool. Here's manual. Anybody recognize that? That looks very familiar to me. I think that might be from a Mitsubishi. I think that's a Mitsubishi right there. So blower speed is manual. This is going to have a resistor. This is going to change your mode, and this is going to change your temperature. It's now these may be cable, but this also might be vacuum, and it also it could be electronic. If it's electronic, that means it's got to have a module involved. Only way to control that is if you computerize it. Yeah, definitely. And then there's a semi-automatic where you can set the temperature, but it won't control the blower. Here's a fully automatic. You set it at whatever I wouldn't do for 85, not today. Set it at 60. It'll control the blower, everything. So if it's really hot, the blower will ramp up. If it starts to get closer, the blower will back off a little bit. It'll change the temperature door, change all that. Cool. Yeah, and there's a dual zone like we talked about. Rear can be a little bit weird. They vary from model to model, but the rear will have its own heater core. It'll have its own blower motor. It'll have its own evaporator core. A lot of times it'll have its own control panel. So you can turn the rear on or off on this minivan, and the people, not necessarily kids in the back seat, can have control, or you can take it over. One or the other. And then cable, vacuum, electrical. Electrical is going to be where we put our time, because that's most important. And then they did have some Toyotas where you could actually press AC, and if it was a hybrid, it would actually run the compressor and start cooling the car off. But shoot, we can do better than that now. I mean, that was cool back in the day, but now we can go all sorts of crazy if you want. I'll show you one example. Let me stop the share for a quick second. So if you guys want to see just how cool some stuff is, I have to do this in the mirror. So, I mean, you want to adjust, we can set the temperature right now. I could power the car on. We could run heated seats. We could power the AC on. Oh, I'll do it. Just gotta hit the button. Boom, AC's on. See the air blowing out? AC's on in our Tesla right now. Don't even have to turn the car on. It turned on right there. I think my dog's heard it click. You'll hear a little bit of noise. Turn it back off. Right, pretty neat. You know what I mean? She's the one who wants the car. Okay, I could also put the windows up and down and all that type of junk. What I didn't pay for was the monthly subscription where I can summon the car to come pick me up. Be like, come get me. Car will just drive over. Pretty wild. You know, I don't care that much about that. So not trying to flex. I'd rather drive a hoopty piece of crap anyway. You see me show up on my bike. My bike's older than just about all your cars. It's a 02. So hybrid offers a couple unique advantages. The compressor is electric driven. So if we want to run the AC, we can power the AC compressor, we can power the condenser fan, we can get cooling to occur, and the engine is off. Make sense? If it's a full-on EV, you can do all that stuff and there is no engine. Where does the power come from then? How can we run the AC without an engine? What? Coming from big battery. So as we talked about in the beginning, on these hybrid and electric vehicles, that compressor is not like 12 volts. That's going to have either high voltage DC or more likely three-phase AC going to that motor and running the three-phase motor directly from the inverter, and the inverter is pulling power from the big battery. Cool. Very nice. Very nice. And then so you can see right here, it's going to do, there could be different designs, but ultimately it's driven by three-phase AC, typically, or it could be DC, like I said. Okay, you guys made it. I think mostly we're rocking. Let's see here. This one did give just a little more complexity on the specifics. The AC ECU can control the control part of, if you look at this blower motor, it's like, why does a blower have a positive, a negative in this thing, SI? This is actually giving the pulse width or the duty cycle. So there's a module in here, and it's going to basically take that signal, and that's going to determine how much current flows with on and off time. It's going to run it up. This one shows a little bit better. We may have.
We can't see the screen anymore.
Dang it! Thank you. Totally forgot. Thank you. Thank you. Thank you. All right. Where's my Zoom controls? Oh, I see that in the chat. I see that in the chat. Share screen. You didn't really miss much. So on the hybrid stuff, no biggie. That was, I'll show you what you missed. Wasn't much. It's just showing the AC compressor being electrical. No compressor clutch, no nothing. Just high voltage connector and boom, it's running. Cool. So then the next one was here. Okay, here we go. So this blower motor has a big positive, a big negative, and a small wire right here. This is the one that carries the pulse width modulation or the duty cycle. So depending on what this does, it'll determine how much current flows through the motor. Cool. And this one has a blower motor controller that's separate from the motor. So if it looks like this, it's got the field effect transistor inside. And if it looks like this, it's got just the motor and the controller someplace else. Could be either one, but ultimately the SI is the duty cycle, and the duty cycle is going to control how much ground the blower motor gets, right? So 12 volts is going to be constant in a lot of cases, but the ground will be pulsed on and off. And the thing is that if you figure that ECU, let's call it the ECU, just for Universal Electronic Control Unit, ECUs don't play games with big amps, okay? Big amperage and small circuits don't play well. So the AC ECU is going to give a little duty cycle, and the duty cycle is going to use a transistor, like a field effect transistor, and the transistor can handle big power, but it has to be basically told what to do. Make sense? So if you're looking at this style, this thing's going to be able to handle big amps. This thing is going to be good for making a signal. And this blower motor controller is going to be good for receiving the signal and then therefore controlling the big amp. So if you had a blower motor that was in op on this style, you could check to see if the blower motor is getting 12 volts in ground. If the blower motor is getting 12 volts in ground and it's not working, it's no good. But if the blower motor is, let's say, getting 12 volts on 2 but no ground, you'd have to actually troubleshoot this blower motor controller. And the blower motor controller needs 12 volts coming in. It needs ground to the chassis. And then it really needs duty cycle right here. Make sense? So you could do 12 volts ground, boom, that's quick. And then duty cycle. Remind me how we check that. How we check that duty cycle?
With a picoscope.
You could go full pico if you want. Yeah, or you could use the Fluke 87 or 88V that has duty cycle function, and you could just get a number off it too. Yeah, you could do it a couple different ways. I'd probably use the meter because I can set it up quicker. Cabin air filter are pretty good. Some of them may actually have a plasma cluster generator, which will pull ozone emissions out of it electronically. It's kind of interesting. It's like an air purifier, basically. Pretty cool, pretty cool. And then we're pretty rocking on this one. This is just showing just how complex some of these can be. So air comes in, either recirc or fresh air, goes through the evaporator, can go several different ways, depending on it's for the passenger or the driver. Can go to these vents, floor vents, rear vents, face vent. They can be, a lot of times if a car has basic rear AC, it's just sending air under the seat. Some of the cars have cooled seats, which a lot of times has its own blower motor in the seat. But a lot of times still pulls the cool air from the regular AC. Heated seats are typically electric heat. So some of this is some of the later things that we cover. Cool. So this mostly gets it. You can see on the dual zone, you'll see distinctly there is a temperature door for the driver and a temperature door for the passenger. Totally separate, independent, right? So that heater core has to slide through a separator, and air is isolated for the passenger and isolated for the driver. Cool, not real crazy. I think you guys get it. The other thing is on some of the older Toyotas, they weren't using doors. They were using these film design. So they called it mode control film or mode control film, air control films. So basically what we would do if you wanted, let's say air at the vent, the windshield, this would actually turn and roll this film so that air would go up. And if you wanted at the feet, it would actually roll and lower it down and it would come out at the feet. It's kind of crazy. It works the same. The way we diagnosed it was pretty much the same. If it's a broken door, the HVAC box is coming out. If it's a broken film, the HVAC box is coming out. You know, so like all we're really doing is making sure that the motor and the actuator work. Sometimes that takes disconnecting it and moving the door. And if the door is messed up, you can feel it. So like some of the messed up doors I've had, one of them I recall specifically, the door was jammed, couldn't move it at all, ended up having to strip the dash, pull it apart. What do you think jammed the door up? I'll give you a clue. It came in as a warranty concern and it wasn't covered. Kids were playing slot machine. Kids shoved a pencil down the vent and it fell down in and jammed the door up. So, you know, when the manufacturer, when Toyota's going to call the part back and the door's not broken and they can see a broken pencil wedged in it, that's going to be hard to get covered under warranty. Make sense? So we had to explain that to the customer. Hey, somebody threw some pencils and colored pencils. There's a whole bunch of junk down in there, coins and all sorts of stuff. So kind of crazy. Here's one with a detached membrane. So this one, you won't have proper control because the plastic is ripped off. Kind of a weird design, I'd admit, right? So there could be quite a few different types. Cool. Now with that, as much we're going to cover, we will do a little more on the auto HVAC stuff. Some of the things we're going to do in the lab are going to be, you took apart HVAC boxes, but we're going to pull HVAC boxes apart again, really focusing on the doors and where they go and identifying each door. Additionally, we're going to do a lot of wiring diagram stuff, which will be a little bit more lecture stuff. And we do have a full HVAC unit that you can see all the movement and everything like that. And we can also do a rotation of setting up some blower type faults, taking some measurements. Be cool to get the Pico set up. We can see a Pico scope reading. We can see a reading with one of the flukes. Right. So at the end of, let's say, Wednesday, you should be pretty rocking, which is good because Thursday we can move on and cover some more of the, oh, I'm sorry, Thursday is the T10 graduation. So by the end of Wednesday, you should be pretty solid. Thursday is the T10 graduation. We'll need some help setting up. We'll talk a little bit more about that in person. And then Monday will be our final Zoom, our final lecture. Tuesday we get into the hybrid and we're pretty much done. And then probably the second half of Tuesday, and I'm sorry, did I mess that up? Thursday is 4th of July. I totally goofed that. Then next week, one more Zoom, and that'll be for mostly diag and prep. and Marty, you just told me, thank you for correcting me. Tuesday is gonna be the last day to do any sort of hybrid work or anything. And Tuesday will be beginning the ASE prep. Wednesday we'll dial the ASE prep, we'll be totally done. And then that Thursday is T10 graduation. There will be, you guys can help, you guys can have some meals. We definitely need some help setting up.